math learners, welcome to Lesson 3, Features of the Graph of a Hyperbola. Before we begin, do not forget to click subscribe and click the notification bell so that you get notified whenever I post new video lessons online. This is Teacher Beth, and let's begin! Let us now discuss the features of a hyperbola. So, in this illustration, this is our focus, f sub 1, one of our foci, and this is our second focus, f sub 2. So, this is the center of our hyperbola, center at the origin, and by the way, this graph describes the graph of a hyperbola with equation x squared over a squared minus y squared over b squared equal to 1. This point here is one of our vertices. We call this one v sub 1. And this is another vertex. We call this v sub 2. From f sub 1 to the center of our hyperbola, the length is c units. So f sub 1 is c units away from the center, and so is f sub 2. F sub 2 is also c units away from the center. While the vertices, vertex 1 is a units away from the center, and so is vertex 2. It's also a units away from the center. Therefore, the coordinates of v sub 2 is a0, the coordinates of v sub 1 is negative a0, the coordinates of f sub 1 is negative c0, and the coordinates of f sub 2 is c0. As you can see here, c is longer than a, and these are the two branches of our hyperbola, and these two branches, same with an ellipse, tries to devour our focus. So it faces towards our focus. Therefore, from here, we can say that f sub 1 to f sub 2, the segment has a length of 2c, and v sub 1 to v sub 2, this segment has a length of 2a. If we have a hyperbola of the equation x squared over a squared minus y squared over b squared equal to 1, the center would be at 0, 0. So if we try to identify it here, given this graph, the center is at 0, 0. This is our center at 0, 0. Again, this is our focus, f sub 1, and this is our second focus, f sub 2. The coordinates of f sub 1 is negative c0. F sub 2 is at c0. This is v sub 1 with coordinates a0, negative a0. V sub 2 with coordinates a0. So here, our foci is collinear with the center of our hyperbola, and so the foci is at plus minus c0. The vertices is also collinear with the foci and the center, and it has coordinates plus minus a0. Here, obviously, we have c0 and negative c0 as the coordinates of our foci. And for our vertices, we have a0 and negative a0 as the endpoints of this segment joining v sub 1 to v sub 2, or the coordinates of our vertices. This segment joining v sub 1 to v sub 2 is actually called the transverse axis. So, the transverse axis in this illustration is horizontal. The two vertices are the endpoints of the transverse axis. We can also have another axis that's perpendicular to our transverse axis. And if the transverse axis is from v sub 1 to v sub 2, this is from v sub 1 to v sub 2, we have another axis that's perpendicular to that, and this particular axis is perpendicular to our transverse axis at the origin. Therefore, this axis passes through the origin, and we call this one the conjugate axis. And the conjugate axis here, because our transverse axis is horizontal, and the conjugate axis is perpendicular to the transverse axis, therefore the conjugate axis is vertical. And this conjugate axis has a length of 2b. The length of the transverse axis is 2a. This one is a from this point to v sub 2 is 2a, because v sub 1 to the center is a, and from the center to v sub 2 is also equal to a. Now, the conjugate axis is vertical. It is perpendicular to the transverse axis at the origin. So it looks like this. If the length from the center to this point here, if this is b, and this is also b, therefore, this point and this point are the endpoints of our conjugate axis. So the conjugate axis is vertical and it has a length of 2b for the equation x squared over a squared minus y squared over b squared equal to 1. From the transverse axis and the conjugate axis, we can actually come up with a figure. So the figure that can be formed here, if we try to make a segment out of that, and this here, and that, and this, the figure that can be formed is a rectangle. And this rectangle is actually called the auxiliary rectangle. Why auxiliary? Because this rectangle will aid us in finding the asymptotes of our hyperbola. The asymptotes are lines of which the branches of our hyperbola tends to get closer and closer as it is being extended. And these asymptotes are the extended diagonals of our rectangle. So when we draw the diagonals of our rectangle, this is one of the diagonals of our rectangle, and this is another diagonal of our auxiliary rectangle. When we try to extend this diagonal becomes an asymptote of our hyperbola, where the branches of the hyperbola will try to get closer and closer to, but will never touch as it extends to infinity. And these asymptotes will aid us in graphing our hyperbola. The asymptotes of the hyperbola can be solved by equating the equation of a hyperbola in standard form into 0. So instead of x squared over a squared minus y squared over b squared equal to 1, we will equate this to 0 and we will try to solve for the value of y. And from there, we will be able to come up with the equation of the asymptotes. And given this equation of the hyperbola in standard form, the equation of our asymptotes is y equal to plus minus b over a x, which tells us that we actually have y equal to b over ax and y equal to negative b over ax as our asymptotes. So this line here, this asymptote, has an equation of y equal to b over ax, and the other asymptote has an equation of y equal to negative b over ax. And these are the features of our hyperbola with equation x squared over a squared minus y squared over b squared equal to 1. That's it, math learners! I hope you have learned something today as we explored on the features of a hyperbola with equation x squared over a squared minus y squared over b squared equal to 1. Stay safe always! Bye!